Hi, everyone. Let's see. I'm here today to talk to you about the next 10 years of crypto and the challenges ahead, where we are today, and how we're going to get to the glorious future. So let me start. Let me start this. Okay, and share screen. Um, let's get started with this presentation. So it's been 10 years since Satoshi came and showed the world how a decentralized currency could completely revolutionize the world. There had been many efforts before him, and in the 90s we had peer-to-peer cash of different kinds. We had the visionary work from the early cryptographers, but many of those did not exactly have the lack of a decentralized mint. One of the early efforts was in the space from my group in 2002. The very first PAL minted coin came from my group called Karma, and but none of them took off. And Satoshi came in with a fantastic new invention, a new consensus protocol that truly changed the game. And today I want to tell you where we are and where we're headed and how to get there. So crypto is here to stay. I hate looking at these market cap charts. I'm sure many of you do as well. They don't mean anything. In fact, these numbers are tiny. So the combined market cap of all of the cryptocurrencies is about 200 billion, and that's used to sound a lot to me, but it's nothing. It's absolutely nothing compared to what it could be. This number is going to be in the trillions. And not too long from now. In about 10 years, we're going to see $1 trillion combined market cap. And there's a lot of momentum in this space, so much momentum that even the stolid old blue chip companies are now trying to enter the game with their, decentralized and name-only currencies. So a lot is happening. And if we take a step back and look at do a meta-analysis of what's really taking place, well, we have a lot of contestants, about maybe 6,000 of them, I think, at the last count. 6,000 different coins, 6,000 different projects. Almost all of them are converging in their product offerings. Almost all of them are undifferentiated. Almost all of these communities are fighting each other because they see every other coin as a competitor. They think everybody is a competitor to Bitcoin. They think everybody wants to be Bitcoin and wants to be cash. They think everybody is going to emerge as an Ethereum killer. Ethereum itself is trying to be an Ethereum killer. Ethereum 2.0 is an Ethereum killer for Ethereum 1.0. So they think that everybody is in the same game, and in fact, most people are in that exact same game. The game is much bigger than what these people think it is. It is not just a $200 billion game. It's far bigger, and the downstream effects for society are far bigger than what people think. So in about another 10 years, there's going to be, again, maybe more than 6,000 projects. And again, there will be a long tail of lots and lots of crappy little ideas, lots and lots of coins that got started on one little technical insight or one little fix. Academics are very, very used to this. A lot of academic papers take a well-established field, change it in some slight fashion. And I'll pick on something that's, let's just pick on some. They pick typically something like a worst-case scenario that never happens in practice. They fix that worst-case scenario, and then voila, they've got a coin. They try to push it. At least academic papers push it. Other academics have to go and cite those papers, etc. None of these have any impact in the real world. We are going to have many thousands of projects, but at the end of the day, a few will carry the day. And today I want to talk to you about what it takes to carry the day. So in the last 10 years, we saw that there are three big problems in the space of blockchains. I think Richard Feynman always told all of the young physicists to always focus on the big problems in their area. You don't want to be an also-ran that fixed some problem that doesn't matter. So, for example, compaction of the blockchain. It's a problem. Is it the burning problem of our times? No, absolutely not. And I can name a gazillion other projects like this that are fixing something, but it's not the thing to fix. So then what is the thing to fix? What should we be doing? We saw the success of Bitcoin. We saw the success of Ethereum. We saw the success of various other coins in their respective fields. Well, what is it that we kind of need to do here that's left? Well, the number one big problem is scale. These first generation platforms that we have seen to date cannot support the scale required for digital assets at global scale. So if you look at the current existing systems, not one of them manages to break 4 digits. And I remember a very, very pivotal conversation maybe 3 years ago in Malta at a conference with some of the Bitcoin core developers. And they looked at me and they said, look, we could make the blocks bigger, a little bigger. We can't make it arbitrarily bigger. And they're absolutely right. If you make them insanely big, like Fake Toshi suggests, then you're going to get into a situation where you've given up on decentralization. So then what the heck are you doing? We could make them a little bigger, but we will never be able to compete with Visa. So these systems cannot work to become payment at scale at the first layer, at layer 1. And they were right. With the technology that existed back then, it was impossible to compete with Visa. Scale was just impossible to achieve without giving up decentralization. And decentralization is the most important property that can never be compromised on. So let's see. So the second issue, of course, is usability. That is, all of these networks offer the same lowest common denominator service. All of them have essentially the same API or the same model, same approach to the network. And there's a good reason for it. That's because they copied it all from Satoshi. And they all share a unified worldview. And I will talk about how that view is so constraining for the next generation to come. And then the last one is governance and change. These platforms need to be able to evolve with the changing needs of users. The world is not a static place. We are living through, even as we speak, an enormous time of enormous economic change. The macro parameters of the economy are changing constantly. We have to be able to change the rate of issuance for new coins, the reward rate for existing systems, and so on. The DeFi systems need to evolve. So how do you do that evolution in a manner that actually respects the participants of these platforms? How do you not ossify your protocol? That's really the big question. So there are these 3 issues. Unless you solve them, I posit to you that these technologies will forever be stuck in the hands of us techies who are forward-looking and who are really extremely eager to adopt new technologies, but these technologies will not break out into the mainstream. So we have to fix these 3 problems. Now let's go back and go talk a little bit about my favorite topic, which is distributed systems. And let's talk a little bit about sort of the big breakthroughs in it. There really are only 3 big breakthroughs in these systems. So a lot of people think that cryptocurrencies are about crypto. They're not. Crypto is a sideshow. Crypto is, yes, it's foundational. Yes, it's there, but it's mostly a black box building block. It's just, we just use commodity crypto results, mostly from the 1980s. And Bitcoin's crypto usage, for example, is not at all sophisticated. It simply uses encryption. It simply uses signatures and elliptic curves for the bulk of its operation. What's really revolutionary here are the consensus protocols. And those are the means by which these systems come to agreement on the financial state of the world. Now, when it comes to consensus protocols, the field was laid out starting in the 70s. And it started with the work of 2 people, both of whom have Turing Awards. These are the Nobel Prize equivalents in my area. These 2 respected people, Professor Liskov and Leslie Lamport, set out for us the definition of what it means to have consensus in a network with Byzantine actors and how to achieve it. And they came up with protocols that are voting-based. So I have a set of people who are eligible to vote, and they vote on which transactions should be finalized. All of these classical protocols rely on all-to-all messaging. They rely on a node for it to make a decision on finalization of a transaction. They rely on that node having heard from everybody else who's in a position to make a decision. What that means is these protocols work okay as long as you have small numbers of participants. If you have up to about 100, Sure, they'll work fine. The same way our voting protocols in the United States Senate work with 100 senators, no problem, these protocols will work as well. But because everybody has to hear from everybody else, you have n-squared communication. You don't have to necessarily immediately talk to them one by one directly, but if you're getting data from all n people, at the end of the day, you have to collect n, and all n people have to collect n pieces of information, yielding n-squared communication overhead. And that is onerous. Now, the best of these classical protocols was invented recently. It was invented by Ted Yin. Ted Yin is a PhD student in my group at Cornell. He did it when he was off on the West Coast. And that protocol is currently used by Facebook's Libra. It is the best classical protocol. And Facebook, when it was picking this, it said, we would like to scale as high as possible, but we cannot expect to scale more than to more than 100 participants. And today you have the Facebook Libra situation, which we have now, which is Mark Zuckerberg and his 28 best cronies have created a cartel that they are using. So those are classical protocols. When I look at the efforts in this space, I see a lot of new systems coming online. They realize that they need something a little better than what exists, and they end up trying to revive some classical protocols. So EOS, for example, is a signature accrual mechanism. ETH2O is using ideas, again, that are very much based on signature accrual. These protocols are all classical in nature. They rely on signatures coming in from all of the people who are participating in that round of decisions. So acquiring those signatures means that in each round you have you have to have a small number of participants. If you have tens of thousands, those protocols will not work. Now, the genius of Satoshi Nakamoto, of course, was that he came up in 2009 with his consensus protocol. And it's a brilliant protocol, and it did away with the need for everybody to communicate with everybody. And it also did away with everybody having to know the identities of everybody else. So the only problem, of course, was that it requires mining. And mining initially was okay when you could do it on your CPU. It was perhaps okay when you could do it on GPUs, but today it is not. Today, to have any kind of a voice in these systems, you have to have a giant GPU farm, and you have to have an electricity carrier coming into your farm that's thicker than my leg for you to have a meaningful voice in these systems. Now, all of these systems, of course, then suffer from de facto centralization. There are only a few dozen mining pools in any POW mined currency. That's about it. Now, these mining pools, could they break up? Maybe. But under what circumstances would they break up? It's not as if these participants are smart enough to be able to know when their pools are misbehaving. We've seen pools misused all the time. And at the end of the day, do you really want to be part of a system where people with electricity, people are consuming electricity, burning it, melting the planet down? That's what they have to do in order to keep track of their ledger. Now, the big event in this space happened 2 years ago. In 2018, a team calling itself Team Rocket came up with a new protocol, and it works entirely differently from everybody else's. Now, I talked about POW protocols and layer 2. Layer 2, so some people will say layer 2 solves a lot of problems. Layer 2 doesn't solve layer 2 solves some problems, but it introduces many others. It introduces a capacity problem. Today, you cannot use LN for really large transactions. It creates a privacy problem. You can have your private transactions monitored through LN, and there are a bunch of research papers coming out and soon to come out in that space. And there is inherent centralization, as I mentioned before. And if you think these systems could potentially serve as a store of value, well, they're constantly leaking value to the power plants. So they're constantly consuming energy. About $5 billion worth of electricity are getting spent there, and that is a big problem. So the proof of stake protocols, as I mentioned, they cannot scale beyond a few hundred validators. They trade off decentralization, and they're not robust, and they're not fragile. They're very fragile. Okay, so we need new algorithmic foundations. I want to talk to you about the Avalanche approach to consensus. The key idea in Avalanche is that we have a protocol that is leaderless, where any number of participants can join. All participants have a voice, And they use a revolutionary new probabilistic protocol for coming to a decision very, very quickly. This protocol is quiescent, so when there is no work to do, you get to do nothing. It's green, there's no mining, and it scales with increasing numbers of participants. This is something that no other protocol can say. You can have millions of Avalanche participants. You can be one of many millions of people participating, and you will have a voice within Avalanche with your laptop, potentially with your cell phone. If we were to look at how these systems stack up against each other, Nakamoto is incredibly robust. As we all know, it has high latency, it has low throughput, it is not lightweight, requires miners to have a lot of machinery, it consumes a lot of energy, cannot handle greater than 51% adversaries, and it suffers from lack of scale. Avalanche actually has some interesting features. It's robust, so we don't have to all agree on who's in the system. We're not going to seek individual votes. It achieves very quick finality. In Avalanche, we achieve about 1 to 2 seconds. So something is final within a second or two. Now, for comparison, that would take about an hour on Bitcoin. That level of finality in Avalanche takes 1 to 2 seconds. The throughputs are very, very high. My testnet is getting, at the moment, on the order of 6,500 transactions per second. Visa gets, by their own blog posts, about 1,700 transactions per second. They can peak to larger numbers, but they can sustain 1,700. And we are about 3 times to 4 times faster than Visa. So that's an amazing thing to be able to say. I never thought we'd be able to do that in my lifetime, and a completely new approach to consensus allows us to achieve that. It's very lightweight, it's very low energy, and one of the interesting things is if there's an adversary that has amassed more than 51% of the voting power in the system can still retain its safety. It cannot make forward progress in the presence of such a huge adversary, but it can at least retain the current balances. And it's very, very scalable. So let me maybe tell you a little bit about how it works. So these are the performance numbers I mentioned. So if I look at what it does, it's just super fast. The throughputs are very high, and security is incredibly high. Millions of participants. There's no notion of serving a subpoena. I think, and I worry about people actually serving subpoenas on miners. And in fact, some miners may have been served with subpoenas. For all we know, there is actual censorship that could be taking place on these networks, and well, at least by partial censorship taking place on these networks. The protocols are resilient to censorship, that's true, but it's not out of the question for people to go after 19 miners. And these slides are old. The Ethereum miner number has changed since I made the slide. I think it's higher, like it's 36 or 40 something these days. But it doesn't matter. The main point stands that that Avalanche can scale to millions of participants. And so one of the interesting things about the Avalanche protocol is that it degrades gracefully. So a lot of these other protocols, if somebody is able to achieve 33% of control over the network, then they own the network. They completely can break down safety. That is not true for Avalanche. Avalanche is robust. It's going to be targeting a particular Byzantine presence. And if it's targeting, let's say, 33% Byzantine presence, and it's guaranteeing that no safety violations will happen for 10,000 years, and even in the presence of 33% attackers. If the attacker turns out to be 40%, that guarantee, of course, goes out the door. But it doesn't disappear. The attacker doesn't immediately win. His chances of winning go from once every 10,000 years to something like once every 2,000 years. So it's very robust, and it's it degrades very gracefully. So now let's shift gears. I don't want to talk too much about scalability, and I don't want to get into the details of how the protocol works, except to say that it relies on metastability. It relies on setting up a dynamic that isn't stable until we've all come to a decision. So the nodes participating in this system, they're designed to be sort of like edgy teenagers, and they will just do what their friends are doing. And anybody who's hung out with them knows that these kids, the edgy teenagers, will all just suddenly turn, one way or another. And then maybe they go emo, maybe they go punk, but whatever they do as a group, and they don't remain stable in a setting where each and every individual does their hair differently. So what does that mean? How does that really work when it comes to consensus protocols? Well, in reality, the way this protocol works is quite simple. It works in repeated rounds, where everybody asks a small number of the nodes in the network which of the multiple double spends they should adopt. And they do this repeatedly. And it turns out that even if you're in a giant setting, like let's say in a big stadium, if you're repeating this process and asking people, hey, I have a decision to make between red and blue, which one do you favor? And you ask 3 people. In a giant stadium, you're not asking everybody, you're asking just those 3 that you know. You get back some feedback, and based on that feedback, you modify what you're doing. It turns out that this process, if you follow the exact protocols that are laid out in the Team Rocket paper, will collapse very, very quickly. In about 15 to 20 rounds, in a stadium full of tens of thousands of people, everybody who's honest will come to the same decision. So that allows these systems to resolve double spends very quickly. So that's the main idea behind Avalanche for Avalanche's approach to scalability. Now, if that's all I had, then I would simply say, hey, I have a cool result, and maybe other people should adopt it, and so forth. But we looked at this and we said, look, this Team Rocket paper is amazing. It fixes the scale problem, but we also have to fix the remaining problems. There's more than one in this space. That's why you see these, one-off little number trick projects not go anywhere, because they are only trying to fix one little thing at a time, and often they're missing the forest for the trees. The second big problem is usability. Everybody is trying to do the same thing here. They have inherited their network model from Bitcoin. And what is that model? Well, Bitcoin has a single unified network with a single token, a single virtual machine, and a single network that implements that virtual machine. The rules embodied in Bitcoin are uniform no matter where you are. And there's only one network. And this is the model that everybody else adopts. You buy into coin X, whatever coin that might be. It's got its own virtual machine. And then you shill the crap out of it. You try to get other people to buy into it. And that's what you've got. That network is extra legal. It is not part of any legal system we can point to. It doesn't integrate into existing systems. If you're a financial, if you work in the finance industry, you know how difficult it is to actually interact with blockchains. It's because they are not part of our legal universe. Now, to a techie, this might sound weird, but talk to any lawyer, and they will tell, lesson number 1 is jurisdiction. Okay, so there's no Bitcoin jurisdiction. It's extra legal. It embodies only its own rules. And this makes it a poor foundation for building things on top. Imagine that you're a company, an enterprise that wants to issue digital assets, and you want to control what happens to these assets. How are you going to do this? You cannot just let this thing be in the hands of, you could issue it on any kind of a public network, but there is no legal foundation for you to go to. When people say, well, what did you do? Like, what is this thing governed by? There is no proper answer. That thing is governed by whoever the least common denominator nodes that make up this network that implement that virtual machine. And here is where I think the big difference comes in with Avalanche and other coins. In Avalanche, from the get-go, we have the idea that we are here to enable many other coins to be issued on top. Each and every one of these coins can come with its own virtual machine. You want to build a real estate engine where coins can be merged if they're adjacent. You can do that. You want to build something else that has privacy guarantees. You can do that. So these virtual machines, there's not just one, but there will be many on top of Avalanche. Even today, there are 2, and we're working on, so there is the Ava virtual machine, and there's also the Ethereum virtual machine working on top of Avalanche. And we plan to bring online the WASM virtual machine that we've been working on as well. And just like this, we envision that there will be many other virtual machines. And most importantly, there will be many other kinds of what we call subnetworks supporting these coins. So you could imagine, for example, having a US-based set of nodes that are under US jurisdiction and agree to abide by its laws. So if tomorrow there's some kind of ruling on how this, that, and the other must be managed, how a real estate coin must be managed, those nodes have signed an agreement or by default are part of a network that obeys that law, and therefore it makes sense to be able to issue coins or assets on top of that subnetwork. On the flip side, if you want to have a GDPR compliant system, you can do that on top of an Avalanche subnetwork. There's the default network in Avalanche that's identical to every other public coin, but these other subnetworks allow us to accommodate people with specific needs. You can, for example, create subnetworks where the nodes have to have additional resources. This is not something you could express in a smart contract. This is extra contract. So essentially this says, if you want to be part of my network, you got to be faster, or you got to have more memory, etc. We're going to change a bunch of numbers. Now, instead of having splits and forks, one can have specialized subnetworks with different kinds of nodes. If you don't like the idea of a legal foundation, and I know there are many libertarians who eschew any kind of law, then the idea is that if you want to be part of a network like this, or rather, one can create subnetworks where those people who want to be a part of that network voluntarily sign an agreement and say that they will obey some set of rules, so that as a token issuer, you understand and can control the full life cycle of your asset. So that's essentially what I described here. One of the final big challenges here is governance. So the Avalanche operation, the protocol itself, lends itself to natural governance. And the system essentially implements a crowd oracle. And one of the ways that we're using this crowd oracle is to make decisions on key economic parameters that other systems bake in. So in Avalanche, key elements like minimum stake, minimum staking period, minting rate, and others are things that people can vote on. And these things can be changed within reason by the people who hold stake in the system. Now, when I say within reason, what I mean is I want to build systems that are predictable. I grew up in a country where there was no economic predictability. You would wake up and your currency would have lost 30%. And this happened multiple times in my lifetime, 30% devaluation overnight. And this is devastating. And I would like to build systems where the economic realities are predictable, where you can step away from the network, come back in, say a month from then, and know by how much things can change. So these amounts can change based on the crowd's wishes, but not by much within a particular time period. So, okay. So where does that take us? I think I will wrap up on the final note, which is the internet was introduced in 1962. A lot of people think it came with Mozilla. That's the World Wide Web. The internet was around for a long time before the web came around. And the web allowed other people to use the internet in an economically effective fashion. Until that point, it underwent many cycles. Even things that today go by the name Ethernet have gone through an enormous set of technological modifications. The Ethernet I use today looks nothing like the Ethernet I used when I started going to university. So it's expected that tech stacks change over time. And it's almost never the case in tech that the first generation wins out and keeps the older generations from going forward. So having said this, I want to make sure that everybody understands that Avalanche is targeting a set of use cases with these three innovations that are different from the ones that are targeted by the main currencies. We are not trying to compete with the US dollar. We are not trying to do what Bitcoin is trying to do. Power to Bitcoin. I hope it wins that battle. I hope it can be a store of value. I hope it can jump over the hurdles in its path. We're not an Ethereum killer. In fact, as I mentioned, Ethereum is currently trying to be an Avalanche killer. It's definitely an Ethereum killer itself. It's trying to kill ETH1. We're not a world computer. We do support the EVM. It's just one of the many things we support. The thing we are going after are all of those assets that can be traded globally without borders, that are not currently in digital form. That is the big market that has trillions of value behind it. And that's where all of the interesting innovations lie. So to this end, we have introduced the Avalanche platform, and it does some amazing things immediately currently on the testnet. If you just simply look at the performance, you will see how fast it is, and you will see how quick to finality it is. And once you see that, there is no going back. Almost everybody else in this space is focused on the wrong metrics. They keep focusing on TPS. And while I've achieved the highest TPS without making a decentralization compromise, I have to say that it's not something that matters. Okay, high TPS, yeah, okay, we've got it. We were like 3 to 4 times faster than Visa in a blockchain setting, in a decentralized setting. But it really isn't the most important thing. The finality, the quick finality, is absolutely amazing. And once you've used it, there's no going back. So I encourage everybody to check out our testnet. And based on that foundation, we're bringing on some services later on, as after we do our mainnet launch, that are going to completely revolutionize services, blockchain services as we know them. Gone is this whole need for very, very slow confirmation times. Gone is this whole idea that you have to submit your transaction and wait many seconds, on the order of 15 seconds to an hour for it to finalize. And that completely changes the world. It completely changes the way we build financial services. So I want to end on this note of saying that the world is ripe for a transformation. We have seen how IT technologies have revolutionized just about everything. They changed the way we do tech, for sure. That happened in the 90s. In the noughts, we saw people come up with things like, I don't know, even like Uber. What it changed was just taxi hailing. So IT applied to taxi hailing gives you a billion-dollar company. Well, we haven't seen IT applied to finance yet. The finance world, which I know very well, I'm talking to you right now from Brooklyn, and I can look out the window at FiDi right in front of me. The technologies they're using are ancient. It's from 1980s. Layers upon layers of CRUD and stories upon stories of people doing reconciliation and vertically integrated, impenetrable markets where assets are very hard to buy, sell, or even digitize. We're going to be changing this with your help and with the aid of some new technologies. I hope you will join us on this journey. Thank you. So are there some, if there's Q&A, I'm not sure how I'm taking them. So the Internet of Blockchains, yeah, Avalanche is a network of networks. So in essence, what we're allowing people to do is we're providing to them the ability to connect sub-networks. We're providing to them what the internet provided to a whole bunch of universities when it arrived. Every university had their own local area network. And the beauty of the internet was that it patched over those differences. So you could have a Princeton network, you could have a Cornell network, you could have a Harvard network, but if you connected to the internet, then those three could connect to each other. Avalanche does a similar thing. So you can create, for example, a GDPR-compliant EU-based subnetwork for, I don't know, something that holds data for people in the European Union. You could have an asset issued and governed by American nodes. And you could have an asset issued by and controlled by other people, let's say 3 different networks. If these are sub-networks on Avalanche, these assets can be traded against each other. They can be a part of atomic swaps. They can be sent from one sub-network to another. And therefore, what you have is a globally unified network that is sharing the same consensus foundation provided by Avalanche. And yet, within a given sub-network, there is full agreement and full understanding of the legal rules in place. When somebody says, you digitize my assets, but what are they governed by? There is an answer. When something unforeseen happens and you have to go to the network and make a change, then there is a process for it. There's a legal foundation for it. So these are things that Avalanche can do that other systems will have difficulty doing. Okay, I'm told that time is up. So thank you all very much for listening to me.